What's up everybody, welcome to another video. Hope you're ready to flex those brain muscles. In this video we're going to practice multiplying binomials using this FOIL method, which is an acronym that helps us remember what exactly multiply together, but it's really just a generalization of the distributive property. Let's go ahead and jump into our first example here. So this acronym FOIL is first, outer, inner, last. And what that means is relative to these terms. So we have two binomials here, which means polynomials with two terms, right? Something plus something or something minus something. That's what we're practicing multiplying together. And what this acronym does is it helps us remember that we first need to multiply the first two terms together. So that's the first one here and the first one here. Then the two outer terms together. So outside to the left, outside on the right. Then the two inner terms together. And then the two last terms. So last, boom. All right, what are we doing with these products? Because I'm saying we're multiplying. Well, we're adding them all together. So it's the sum of these four products that we're going to find. And that's going to be what these two binomials multiplied together is. We just might have to simplify it at the end. So another way to think of it, if you don't like acronyms, is we're just starting with one term in this first binomial, and we're multiplying it by everything in the next one. Then we're moving on to the next term here. We're multiplying that by everything in the next one, right? And actually, if you remember it this way, it's going to be a little bit easier of an adjustment for you to generalize this to polynomials once we have 3-4 terms, right? But let's go ahead and start by doing this. What are the first two terms multiplied together? Well, x times x, that's just x squared. Now the outer terms, we're going to move on to x times, we want to think of this as -5. So that negative is going to stay with the x times -5, and then we just have -5x, right? So we want to think about the signs when we're multiplying these together. So I want to think of this as +3, because there's a plus there, times x, which is plus 3x. And finally, I want to think of this as +3 times -5. So a positive times a negative is a negative, and then 3 times 5 is 15. So we've done the multiplying part. Now we need to do the simplifying part. And if you notice, we have two like terms here. They both have just x in them. So we can copy x squared down because that's the only x squared term. And now we need to combine these like terms, right? So we can add the coefficients together, -5 plus 3, which is -2. And this should make sense because, remember, multiplication is repeated addition. So this is saying we're subtracting 5 of these x's and then adding 3 of them, which is the same as just subtracting 2 of them. So 3 of those minus x's will cancel with 3 of those plus x's. Hopefully that makes some sense. And then at the end, we just have -15. So now we've done the simplified part. We multiplied, we simplified by combining like terms, and that's it. So hopefully you're asking, why does this work? Or maybe you're not. Maybe this is just a rule you've been told by your teacher, FOIL, this works. But I said in the beginning, it's an application of the distributive property, which is this. So this is where I'm going to kind of explain the why. So if you don't care, you can skip ahead to the next example. But I think this stuff is important to think about. So the distributive property tells us we can do this. Boom. Is if we're multiplying a number by a sum like this in parentheses, we can distribute. So this is equal to a times b plus a times c. So it turns out we can actually multiply and simplify to exactly what we just did here by applying this distributive property. It just takes longer. But if we do it, we'll notice a pattern, and that's why we're able to do FOIL, or that's the mathematical kind of basis for it. So let me pick a different color here. All right, so this looks a little bit different than our a times b plus c because we have two binomials, but we're just going to think of this x plus 3 as our a. So let me erase this work real quick. This is our a. We're going to think of this as one thing, and we're going to distribute it in, which is exactly what the distributive property tells us we can do. So what we get when we do that is a, which is x plus 3 in this example, times x, and then plus x plus 3 again. Remember, that's our a here. X plus 3 times -5. And so this is how I'm going to write it. And now what's really cool is we can apply the distributive property again, and I can rearrange to make this a little bit more clear. This multiplication, I'm just going to switch the order of it, which I can do. The order doesn't matter with multiplication. It's what we call commutative. And I can switch the order here. And the only reason why I'm doing this is because now each of these terms better aligns with the distributive property as it's written here, where I'm going boom, boom, right? So notice how I can do that here. Let me switch to blue. Boom, boom, and boom, boom. So let's see what happens when I do that. I get this all equals, and I'm running out of room here, but it's x squared plus 3x. That's what I get when I distribute here. And then we have plus negative 5 times x. I'm just going to write that as minus 5x. And then plus negative 5 times positive 3. Again, I'm just going to write that as minus 15. This is the same thing we got in this step. And it turns out this is what always happens when we apply the distributive property, not just for two binomials, but any two polynomials. We always end up with, one way to think about this is all the combinations of things we can multiply together, we end up with the sum of those. So again, that's how we can think of this, is I'm picking the first thing, I'm multiplying it by everything in the second, and then I'm moving on to the second thing, and I'm multiplying that by everything in the second, and that's always what we end up with when we apply this distributive property. So we're just generalizing it. It's basically a shortcut that allows us to jump straight to here. So kind of cool. Now when your teacher asks you a question about kind of understanding this, or you can kind of show off and be like, hey, do you know where this comes from? Do you know why this method works? All right. Hopefully that was cool for you. I enjoy that. Let's jump into the next example here. First, outer, inner, last. So we're going to start here, and we're going to go boom, boom. That's our first and our outer. Then we're going to move on to the 2, the positive 2, and we're going to go boom, boom. That's our inner, last. All right, what happens when we multiply the first together? 4n times n. That's 4n squared. When we multiply two of these n's together, we get n squared. All right, now I'm going to outer. 4n times positive 5. Let's see, 4 times 5 is 20, and the n is just going to chill there. All right, now moving on to the inner. Plus 2, so positive 2 times n, that's just 2 times n, 2n. And then finally, positive 2 times positive 5. 2 times 5 is 10, so we have a plus 10, and now hopefully we see these two like terms, which is very often the case, but not always. And so what we can do is we can say this all equals our final answer here. We multiplied, and now we are simplifying. We're adding 20 n's and then 2 more for a total of 22 of these n's, and then the plus 10 is chilling out here. So we multiplied, then we simplified by combining the like terms. Awesome. Next example. I love this example because it's one of the most common mistakes kids make, which is they distribute this square. They just square each thing. They say, okay, this is 4x squared plus 9. And this is very wrong. Don't do this. What does square mean? It means multiply by itself. And here's what we always want to do when we see something like this squared, whether it's a binomial, a polynomial. We want to write this out. We want to expand it and say, oh, this is the same thing as 2x plus 3 times 2x plus 3. Now we're multiplying two binomials together. So what's the product of our first terms here? Well, 2 times 2 is 4. And x times x is x squared. And then what about our outer terms? Well, 2 times 3 is 6. The x is just chilling, so plus 6x. Now our two inner terms, 3 times 2 is 6, and the x is chilling again, so plus 6x. And then the last terms, 3 times 3 is 9, and boom. We don't just have 4x squared plus 9. We end up with these x terms, which we can combine. They are like terms. So we've done our multiplication step. Now we are doing our simplify step, which is 4x squared. That doesn't have any like terms. Plus, we have 6x's. We're adding 6 more for a total of 12x's being added together. And then we have the plus 9 out in front chilling. So we've multiplied and we've simplified. All right, we've done a few examples now. So here's your chance to check your understanding. Pause the video, pull out a pencil and a paper, try this on your own, then press play to check your own work. Awesome. I'm going to jump right into it. Hopefully you're checking. You have some kind of an answer. First terms multiplied together. 3 times 2 is 6. Ooh, and now y squared times y. So we have 2 y's multiplied together, and we're multiplying another one for a total of 3 of them multiplied together. That's one way to think of it. You can also remember your exponent rules. When we multiply, we add the exponents 2 plus 1. But I like to think of it just intuitively. This is y times y, and we're multiplying it by another y here. So we have y times y times y. Awesome. All right, now we have 3y squared times 1. That's super easy. That's just 3y squared. Then we have this negative. We need to think about that. We're always thinking about the sign. Minus 4 times 2y. So negative 4 times 2 is negative 8. The y is just chilling. And then we have negative 4 times 1, which is just negative 4. And here's what's cool about this example. We multiplied, and there's actually nothing to simplify. We don't have any like terms. We have a y cubed term, a y squared term, a y term, and a constant term, and sometimes that happens, and that's okay. We don't have any simplifying to do. This is in simplest form, and that's it. Hopefully this video helped. Comment with any questions to support me, like the video and subscribe, but most importantly, keep flexing those brain muscles, and I'll see y'all later.